what I'm going to present right now is, let's go a bit more technical. So first of all, as Magnus said, we're going to be deep into AKS and container stuff. But first, who am I? I am Lucas. I work as a cloud advocate at Microsoft, especially in the container area and containers team. So I mess around Kubernetes and Kata and a lot of service mesh and stuff. So basically, if you want to reach out to me, there is my email. And for everything else, this is my website here at the bottom. Let's see if I can get a pointer. Oh, I can get a pointer. This is my website at the bottom. There are all my social networks. You can ping me around on any of them. I am very eager to answer questions and to help people because I really love technology. Well, we're going to talk about GitHub Actions and AKS. So first things I'm going to explain here is what the problems we're actually facing. Because basically, today, we use CI pipelines for almost everything. So we have CI pipelines for awesome lists, which is awesome because they have an awesome bot that checks all the links and tells you if the link is okay or if it's not. So I use this for my awesome lists and I use this for my node repositories. And this is cool. But the biggest problem of them is that today most of these pipelines are external. So I will explain shortly what I mean by external, but basically the idea is that most of the external tools we have, like Travis, like Circle CI, like Worker, and so on, they are external to our versioning system. So since we're talking about remote communication and remote work and how we can do better in these crazy times, one of the things that we should carry with us is that external tools require external administration too. So being external alone is a problem because mostly of this the problems we face today with CI pipelines is related to being external configured and so on. So I'm gonna list a few problems that I find out, and I'm gonna list and explain everything as I see. So it's my point of view using CIs and CDs for the past, like, I don't know, 5 or 4 years. So basically, external integrations is they are one more layer to care about. So basically, when you're using an external CI pipeline, you need to integrate this with your version control provider like GitHub or GitLab or whatever you're using. And we add another service layer on top of that. So you have like your versioning pipeline, and you add another layer on top of this pipeline because you need to integrate those two services together. So when you use this external version, this external CI pipelines with the external versioning providers, if we need to integrate both of them, we need to add another environment deployment. So we need to, create all this pipeline and all this pipe where we integrate both services and intercommunicate those two. So the more layers we have, the more prone to failure we are, because since we're using external tools, these tools can be unavailable for some reason because they don't depend on the same system. For instance, if you're like GitHub and Travis, they are not the same company. So once Travis can be offline, GitHub can be online, and you have a problem with your CI, or the other way around. GitHub can be offline, and then your Travis pipelines will not integrate in the correct way. Then we have the sync speed. I think this is not much of a problem today because most of the CI pipelines we use are pretty fast, but some of the systems takes a real good while to sync between your push event or whatever event you're actually listening to the real CI pipelining running. So in the beginning, when I started using CIs, this sync was like a minute. I pushed things to my repository. I could take a coffee, I could like drink a coffee, I could eat something, I could go out and take a run because it would take a very long time for it to sync and get my push. With time, this sync speeds started getting faster and faster, and they are now a few seconds, in the worst case a minute. but there's still a few sync speeds, and this is a problem because they're way slower when you're using external tools like external CIs. This is what I mean by external CI, external tools using for continuous integration. Then if you were using them in the same place where your VCS is running. So if you use the same thing, this is what GitLab tried to do in the past by getting the CI inside GitLab, inside of using external tools. So the next problem is downtimes. This is what I explained earlier. Since most of the CIs are created and maintained by other companies, they don't have their own VCSs, like Travis don't have their version controlling systems like GitHub or everything else. You're prone to have downtimes in different parts of your pipeline. So if you have downtime using Circle, you might have your repository up and running and you will not have your test running. If you have a downtime in GitHub, you will not have your pipeline running because one of the parts of the system is off. So this is the layer we add on top of these things since we need to care about them right now. Another thing, that's what I think it's the most complicated, is that every CI provider has their own pipeline syntax file. So basically, GitLab has one syntax, and GitHub has another syntax, and Circle has another syntax, and Travis has another syntax. They are all YAML files, most of them, but each syntax is different. Each CI provides a different technology and a different feature set that they can support, and some of them is not supported, right? So you have to learn, if you have like several CI pipelines, you have to learn each one of them. So when you're working in big teams like Microsoft or any other big companies, you don't need to be so big. You can have like 3 teams working together. Some of those teams can be used in different pipelines, and you have to learn all of them if you're a system admin or if you are like a DevOps admin. So this is a problem. This is an efficiency killer. And the biggest problem of them all is that since we're talking about remote work, more tools adds more complexity to your workload, and more complexity reduces the efficiency you have when working. So when we're talking about remote work, basically you have to be as efficient as possible because you were working asynchronously, basically. So you have to be very assertive in the first place. So you don't have so many room for error, because you simply can't be asking for people to do things because you need to wait. Maybe like a real situation in Microsoft here, some of my colleagues in my team are in Australia, and for me in Brazil I am GMT -3 and Australia is GMT +11, so it's almost 12 hours of difference, and I can't just send up a message because my 4 hours in the afternoon is 4 hours in the morning for them, and they will not answer me until I am asleep. So we need to reduce this error-prone communication. So basically, this is pretty self-explanatory. And the other thing is that when we have more tools, the onboarding process for new people getting into the company or into the team is harder because they'll need to set up their accounts into these providers as well. So it's complicated. And from the sysadmin side, from the people that take care of the CI pipelines and the DevOps side of stuff, this is very less efficient because they need to care more about the security roles and IAM roles and whatever, because it's another layer of security that you need to care about too. And in short, the more tools you add, the more complexity you add to your system, and therefore you have less efficiency. It's like a trade. Every tool you add takes a bit of efficiency off, at least for the first months, but until you configure this. But once you configure everything, it becomes a one-person efficiency killer because someone will be responsible for this tool. And most of the times, the same person that is responsible for the tool is responsible for all the other CI pipelines. So this person basically is hired to take care of tooling, which is a very wrong way to spend your time, unless this is a huge gain to the company. You could be creating more automated stuff and be freeing your time for stuff that actually matter. And besides this, this is just a lot to manage, right? So it's very complicated to manage everything, and sometime you will like be getting out of hand, and things will, you know, be lost. And this GIF is like awesome. I really love it. It's very cool. But basically, when you're working with remote teams, things can go wrong in many ways. So you need to find a solution that takes the less time as possible and be as efficient as possible. Okay, so you need to follow the KISS principle. This is the less the better. I will not explain this all to you and everything, but integration over features. So the less tools you use, the better. The more integrated these tools are, the better. Unless, of course, the features adds more efficiency than the integration itself, which is very hard to measure, because once you realize that the feature is not adding too much efficiency, it's too late. So you're already losing a lot of time. So one of the other problem that we have is that we have to copy things over and over again. So we don't have one single repository. We have more than one repository. And most of the CIs don't come with what we call a step store. And some repetitive things that we do, like I don't know, cloning repositories, installing Node.js, installing Go, you need to, you know, copy over and over again. I did this for GitLab like for several years, and we need to copy. We had a repository only for CI pipeline files, and we need to import those pipeline files using Git submodules. So this is something that it really needs to be taken care of. Some of the providers are already doing this, like Worker and GitHub Actions. So some others are not. So this is a feature that, in my opinion, actually takes a lot of efficiency up, because it won't be taking your time copying stuff from one archive to another, one file to another. Okay, you won't be rewriting stuff. Okay. So you just pack all these small changes you want to do, and in small chunks of code, and this is it. Most of the external tools are not well integrated because they don't support a lot of the VCS providers. They support all the VCS providers, like they support GitHub, they support GitLab, they support Bitbucket, they support like whatever Git, everything that you might find in the web, but they also need to support all the events. So in order to support all these tools at the same time, they need to cut out a few features that actually make them support more one than another. So some specific VCS events like tags and I don't know, releases are not supported in some CI providers, because other VCS providers don't have those you know, abstractions or those concepts. Okay. So what the idea of the ideal pipeline is? What is an ideal pipeline? So it has to follow a few steps. This is for me. This is something that I came up with during the years. So the perfect pipeline needs to be tied up to the smallest number of external tooling as possible. So the CI pipeline needs to be self-contained and auto-sufficient. I'm talking about VCS providers as well. So it needs to be contained and needs to be using the lesser amount of external integrations as possible. It needs to be integrated with your VCS and preferably native. So if you're using if you're using GitLab, try to use the GitLab CI. If you're using GitHub, try to use GitHub Actions like I'm doing. I'm going to show you right now. And it also needs to support a lot of events that your VCS provider has. For instance, GitHub Actions supports the release event, which is not a tagged commit. You can push a tag, but you cannot release this tag. So you can push several tags, but once you go into the GitHub and create a new release, this is where when the pipeline will run actually. So this is one of the things that I'm talking about. You should have a step store. This for me is a must. I don't want to be copying stuff over and over again. One other thing that I forgot to put over here is that it needs to provide the secret support. You have secret files, you have secret like keys and stuff that need to be supported. not only per repository basis, like one repository with their own secrets, but per organization basis. So most of the time, like Azure, you have one Azure subscription that powers up the entire organization. You won't be able to, you won't need to copy those settings over and over again to all the repositories. We tried Travis once, and this was the thing that made us cut Travis out, because it didn't support to take and share secrets. Okay. Another thing, it needs to be simple and objective. It then doesn't need to have like the pipeline description file, the YAML file that describes the workflow that you're gonna run. It needs to be simple and needs to be straightforward. You don't have to like be putting keys inside of keys inside of keys inside of keys just to say that you want to run that in a Node 10 environment instead of the current default environment the CI actually runs. Okay. You have to be able, but in short, you have to be able to write your own scripts without spending too much time on the docs. So I'm gonna introduce you a few heroes of myself that I found out in the last few years. The first one of them is GitHub Actions, of course. Spoiler alert on the title, but GitHub Actions is the build pipeline that was developed by GitHub I think 1 or 2 years back, I don't remember, to automate the process in user repositories, not only deployments, but whatever sort of process you want. It's powered by Actions. Action is a concept that is a repository. This repository can be either powered by simple JavaScript, so your actions can be simple JavaScript files or Docker files, image files that run inside the ACI structure in GitHub. So basically what I'm telling you is that an action doesn't necessarily need to be tied up to infrastructure. You don't need to be deploying stuff. You can write your own action just to, I don't know, to tell your mom that you're working when you push a repository, because you can create a repository called like tell my mom action, and this action is just the JavaScript that, you know, goes to external API and calls your mom, and this is the stuff. So basically that's the extensibility. This is being extensible is one of the things that makes GitHub Actions so great. It supports all GitHub events, of course, because it's inside GitHub. So it supports GitHub entirely. You have a ton of events that you can do, like releases, as I said. It supports filters and a lot of other things straight out of the box in the YAML. It has multiple environments you can test on, like Linux, Windows, and Mac OS. You can test on all of the three if you want. It's free for public repositories, and for private repositories, I think it's 2,000 minutes for all your private repositories, so it's very cheap. I think if you're not using, if you exceed this time, is 0.0018 cents per minute or something like this. And the other hero is Kubernetes. So Kubernetes was created by Google in 2000 as an abstraction for dealing with container orchestration. It came from two other projects called Borg and Omega, but it was just first released in 2015 as an open source project, and now it is maintained by the CNCF, the Cloud Native Computing Foundation, and it's fully open source. You can find out the Kubernetes repository in github.com/Kubernetes, and you have like all the code over there. You can submit pull requests. It's pretty cool. And well, this is our underlying infrastructure that we're going to be using to deploy our application. I'm not be talking about too much about Kubernetes because it's not my intention to show you how it works, but it's my intention to show you how it can work together with GitHub Actions. So why did I choose GitHub Actions instead of whatever thing that is in the market right now? Why did I choose GitHub Actions over GitLab specifically? That's what I used before I joined Microsoft, and well, what I used before in my all projects. Because GitHub Actions, they are very simple and easy to develop. I find, this is my personal opinion, I find the GitLab YAML too difficult. I had to spend like several times you know, I reading the docs to make it work. The docs from the GitHub Actions are very complete. and very extensive. Both of them actually are. They're very good. Both GitLab and GitHub Actions are very good. Aside now just comparing GitHub Actions, since it's newer than the GitLab one, I think that's the point where GitHub actually learned from the others and created their own documentation following the principles for developers today, instead of just laying around everything that needs to be done. Actions are just JavaScript files or Docker files in a repository, and you can create an action and share with the rest of the community. This is super cool, and this is something that actually makes a difference for me, because you can have your actions for your company only. So you can create your actions inside your own repository, and you will not share it with anyone else. But you can create repositories that are only actions. And these actions are open source or closed source, whatever. And you can share these actions with your colleagues, with your co-workers, with your company, with the whole community, with the whole world, like Azure does with the Azure/actions repository. And it has all the actions related to Azure inside that repository, so it's very, very cool. And you can, I found a bug on that thing, so you can just go there and add a PR to fix it, or you can provide new functionality, because it's very, very simple. I won't be teaching you to create a GitHub action right now, but it's basically a YAML file that describes what the action takes as input and what it gives you out as output, and what file it needs to call. It needs to be either a JavaScript file that will be executed using Node, or it can be a Docker file, and you can pass all the arguments inside it. So it's going to build up your image, it's going to run up your image with the repository inside it. It has tons of events, like I said before, so you can actually listen to a lot of things that GitHub does. There is an event called Golem that I didn't even know it existed, but when someone orders the wiki, you trigger the Golem event, so this is very cool. Most of the internal pipelines, when the pipeline is integrated with the VCS itself, like DevOps or GitLab, they have this kinds of stuff. It's native, integrated with GitHub. You can listen to all GitHub events and take advantage of them. You can do incredible integrations using code spaces and so on. And well, since they're native, all events are almost instantaneously. So you push and things just run, and they're fast. So it's easy to start doing things. You can create a workflow by create a repository, go to the Actions tab on the top, and you will be presented with this screen. This screen actually gives you most of the stuff that you want to do. So you can create a simple workflow. It's a basic workflow. You can create deploying code with particular services like Azure, AWS, Google Cloud, and there's a ton of other things below it. So you can do like Node.js deployment, Ruby, Go, and so on. It's all pre-packaged and pre-done. So you just click there and gives you like a template for this integration. Once you create this, like I created a simple workflow, that's when I click on this set up this workflow here, simple workflow. It creates me a file. It's just a YAML file that's put on the .github/workflows folder. It has a name. It happens when these events happen and these branches, and runs these jobs. So it runs a build job that runs on Ubuntu Latest, which is an image for Docker, and it has these steps. So it will check out my repository, it run a one-line script or run a multi-line script. And the right-hand side of the screen, you have all the marketplace for Kubernetes. I don't know like what I'm telling you. So you can deploy things to Kubernetes just by clicking over there, and you have all the documentation for the workflow over there too. The GitHub workflows have IntelliSense, so you don't need to actually look in documentation, just press like Control in space, and you'll be presented with the IntelliSense. So it's very, very cool. This is an IDE. This is based on Monaco, which is the text editor for VS Code, so it's very fast. This is the step store. This is something that is not made by, I don't know, by Microsoft. It's made by this guy, and this one is made by this guy, and this one is made by this guy. So there's a lot of things here that you can actually use, okay? And the other stuff, the docs are in line. So you can just, follow on the docs while you're writing this stuff. You don't need to get out to the other tab or something. So I'm gonna present you a demo right now. Since we don't have much time, I won't be actually coding the demo, so I recorded the demo for you, and I'm gonna be explaining these stuff. So what we're gonna do here is that I have a pre-created cluster on AKS. We have to start on AKS pre-created clusters, as you said over here. And as you can see, I have a namespace called main. So this is where I'm going to deploy my do you see my video over there? Yes, you can see. This is where I'm going to deploy my application. So this is the production environment. I have some delays. So as you can see, I just created my main namespace. You need to have everything. You can create this namespace in GitHub's Actions as well. You can run scripts. There's nothing in the main namespace. So I'm just going to be deploying an application right now. So I go on to my repository. I don't have a workflow. This is my previous workflow. I will create another workflow, and then I'm gonna set up a workflow myself. So this is that thing I showed you in the slides right now. So basically, I just pasted it because I won't be like typing everything. But what I'm gonna do is that this workflow's name is deployed to AKS and runs when I push to a branch called main. And the job runs on Ubuntu as the others. It will check out my repository first, and then we'll set the context to the AKS. As you can see, I'm using a pre-recorded action. So the Azure AKS set context is a action that Azure built, and it sets my current context inside the machine for the Kubernetes. It gets my credentials and everything else. So I don't need to get my credentials for Kubernetes. So this is something that we need to do. I won't be getting into details, but when you are using Azure CLI for SDKs or for applications, you need to create a Active Directory service principal, which is the role binding that will allow you to perform actions on behalf of someone's name or some user's name. So you have to run this command, copy everything, and put on a secret. So the secret file is very easily found. So you can find it very easily on settings and secrets. And this is the name, and this is how you call it, and this is it. It's encrypted, so no one can read it, and doesn't show up on logs. So I'm going to deploy to my cluster, which is located on resource group named demos, and the name of the cluster is G8 actions demo cluster. And this is another action that actually deploys the application itself. So this is another action that I'm taking from Azure, and I'm going to deploy my manifest files, the workloads manifest files over here, to the namespace main, which means I'm going just to put the applications to run on those namespaces. This YAML file is on my code, as you'll see later on. As you can see, this is how I set my context. So I can just click it, and this is the version. You can version all your actions. So you can have a version 1, a version 2, a version 3, and so on. And these are the documentations for both the action and the workload. So it's pretty simple. This is the documentation for all the Azure and all the action you're going to do. So the workload file is just a simple Kubernetes YAML manifest, as you can see. Let me just, so it's just a simple Kubernetes manifest, as you can see over there. It has my deployment, my service, and my ingress. And I don't have anything else to put over there. You can put secrets over there. You can put like variables inside those stuff, and you can just use sed or helm to replace it. So I'm just going to push that out because I'm just getting my DNS zones and put the DNS zones inside the ingress resource. Okay, so I'm going to run this image, which is Scalable Node API, and I'm going to deploy it. So once I'm done, I can just click Start and Commit. I'm going to create the main file and commit it. Once I commit this file, everything will be we'll be running, the action will run because it's a push event. So the action is going to be run, and it's going to log me out everything I have. So it is starting my workflow right now. As you can see, there's nothing on the namespace, so there's no deployments, there's nothing created over there, there's no services or ingresses whatsoever, so it's empty. And when the workflow start running, it needs to download the machine and run the machine, so it's a cold start. It has a cache if you need to run it faster, and it's going to set the environment for my namespace. Yep. Okay. No, I'm going to show on the browser as well. So sure. Okay, so this is finishing. So I'm finishing everything. I'm just thinking about it. So as you can see, everything was deployed right now. It ran everything, so it has my resources over there. The code is not actually very important. You can see it on my repository. I'm gonna be putting the repository on the end of the presentation as well. So just to finish that up, I can go on to my website that I just deployed it, and you will see that is hello world from the pod, whatever. Okay, you can test it on your computer as well. It doesn't need to be on my own. So this is the references I am going to, I did to do everything here. So this is the help for actions. This is a cool tooling to run GitHub Actions locally. These are the AKS workshops for those who want to know Kubernetes. These are the slides that I'm going that I just showed right now, and this is the repository I am using to deploy it. So just a quick glimpse over here. So it has the deployment over there. It has all the workflows. I just opened a code spaces over here, and has the main here, so you can test it on your own machine. Okay. So just to finish off, thank you so much. I think was a bit past time, but if you have any questions, just let me know.